trying to take the derivative of tangent inverse of x. Well, we don't know what the derivative is yet, so we can just say let it equal y. And of course, we know that tangent inverse is an inverse function, so we can also write it like this. This will be useful later when using this theorem over here, the inverse function theorem for derivatives. So rewriting this equation here, in terms of the original, we can say that tangent of y is equal to x. Of course, we could also say that tangent of x is equal to f of x, but of course, in this example, f of x is not equal to y. F inverse of x is equal to y. By rewriting it like this, we can take the derivative of both sides of this equation with respect to x. So if we did that, well, the derivative of x with respect to x is just 1. The derivative of tangent of y with respect to x, well, it's not 0 because 0 cannot equal 1. So here we'd have to use implicit differentiation as well as the chain rule. So pretending that we're doing it with respect to y, well, in general, the derivative of tangent, we figured out in a different video that that was secant squared. So to figure out the derivative of tangent, again, you can use the quotient rule and writing this tangent as sine over cosine. So we know that the derivative of tangent is secant squared. And then multiplying by the derivative of the inside, we get dy dx. And then solving for dy dx, we can divide both sides by secant squared and get this. But what is secant squared? Well, using a trigonometric identity, we know that secant squared minus tangent squared is equal to 1. So that would mean that secant squared is the same thing as 1 plus tangent squared. And what is tangent squared of y? Well, we said that that's equal to x. So this is just the same thing as 1 divided by 1 plus x squared, as seen here. Instead of taking the derivative with respect to x, we can also take it with respect to y. And we don't have to use implicit differentiation. So the derivative of tangent of y with respect to y is secant squared of y. The derivative of x with respect to y is dx dy, but we don't want dx dy, we want dy dx. So we can simply reciprocate both sides of this equation and get 1 over secant squared of y is equal to dy dx. So we flipped both sides of this equation. But what is secant squared of y? Well, we figured out that that is 1 plus tangent squared of y, based off the trigonometric identity. And of course, tangent of y is equal to x. So the derivative, dy dx, is equal to 1 divided by 1 plus x squared. And of course, y is that tangent inverse of x. So in other words, the derivative of tangent inverse of x is equal to 1 divided by 1 plus x squared. So that's doing with respect to x, the derivative. Now let's say we want to use this formula here, the inverse function theorem for derivatives. So we know that we can find the derivative of an inverse function by simply doing 1 divided by f prime of the original function, plugging in the inverse function. And of course, that inverse function is usually just called y. So let's try doing that. So the same thing, tangent inverse of x is equal to y. And we say that y is equal to that inverse function. So if tangent inverse of x is equal to f inverse of x, then f of x, the original, is just equal to tangent of x, the original function. But we don't want f of x, we want f of y. So finding f prime of y, we can say that f prime of y is equal to secant squared. So here we just plugged in a y instead of an x. So what is the derivative of tangent of y? Well, it's secant squared. We figured that out over here, and as well as in another video of why the derivative of tangent is secant squared of y. So we just figured out that the derivative of tangent inverse is 1 divided by f prime of y, or in other words, 1 divided by secant squared of y. And again, what is secant squared of y? Well, it's 1 plus tangent squared of y. And what is tangent of y? Well, if we know that tangent inverse of x is equal to y, then we know that x is equal to tangent of y. So we can just say that this here is the same thing as 1 divided by 1 plus x squared. So again, we just get that the derivative of tangent inverse of x is 1 divided by 1 plus x squared. So here are 3 different ways